tonight we're going to do two things, but the major thing is going to be on antenna analyzers, and Jeff is going to do that for us. And you know, it's a piece of gear that we all have, or hopefully have, or use, but it's really fun to look at the different comparisons. He's going to compare several. Sometime in the future, we have several people in the club who have a Comet. I'll let them do a review on the Comet and how it compares. But I really appreciate Jeff doing it. By the way, we want to congratulate Jeff. He's the new, I think it is vice president of the VHF club, the Inland VHF club. So we congratulate Jeff.
Where?
What's that? I'm sorry, I missed whatever.
The VHF club up there, Spokane?
Yeah, in Spokane, yes. And so we're going to let him take it. And at this point, Jeff, if you want to do a screen share, you can do it. And we'll let you take off.
Unmute. There we go. Now
There you go.
Hear me. Share that screen. Are you guys seeing? Oh, Peter Stewart just joined as well. Mel, might want to let him in.
I did.
You guys see the?
Yes.
Are you seeing? Okay.
Yeah,
Mel, are you guys seeing the screen now with the antenna analyzer stuff?
Right.
Hey, Jeff,
Yes.
We're seeing it.
Good.
if you can go full screen, it would look better.
Yes, I can do that.
There you go.
Now you'll be able to keep track of what's going on. Anyway, basically, I had an MFJ 269 like many other people, you know, and used it for a couple of years and found that it was, you know, a useful tool, but then it broke. I used a cable. It has an end connector, and I used a cable that had a male pin on an end connector that protruded just a little too far, and with continual, you know, connecting, disconnecting, eventually the female part of the end connector, the pins inside broke off. So I had to send it away, and feeling naked and lost without an analyzer, I decided to buy another one and did some research, and I thought the RigExpert 600 fit the bill, simply because, you know, I do a lot of VHF stuff as well, and it goes from DC, well, almost DC, to 600 megahertz, and I'll be talking about that one. Then I had the opportunity to play with an AA54, which obviously only does HF because it goes 54 megahertz. And I thought that was pretty cool, but the 55 was the newer one, and got my hands on one of those and realized that it has what I consider to be newer software than the 600, and I'll show you why later on. Both of them can operate plugged as a standalone unit and also plugged into a computer. And they have some software called AntScope 2, which again, I'll show you what that is. But for those of us that need bigger screens to look at, this is the solution. And then, of course, along came the Nano VNAs, and for $40, I had to have one of those, and tried it out. And obviously, the RigExperts, I was just totally amazed how much easier they were to use than the MFJs. But then I looked at this Nano VNA, and this $40 thing did almost the same stuff the other ones did. And then they came out with the Nano VNA-H, which is basically the same thing, but in a metal can. And then the Nano VNA-F, which is $100 one and with the biggest screen in a metal can as well. And they too have software called Nano VNA Saver software. So I'll be showing you some of that as well. And of course, I'll show you the 269. So this is the RigExpert AA-600. It's around about $484 plus tax. So, you know, you're just around 500-ish. And as I said, it goes 600 megahertz. It's got a color screen. It uses 3 AA batteries, and they can be any variety. Has an N connector. And when they're plugged into a computer, it uses a standard USB to printer type cable. Obviously at that point it's using the USB power, so it saves you a little bit of battery time. And this is what it does. It's you can do your SWR, return loss phase, Smith chart, and a whole bunch more stuff, which we'll get into. It's lightweight, it's comfortable, it's got a rubber body, and the manual, unlike many Chinese manuals, and in fact the non-existent Nano VNA manual, although there are some now online people who've done other manuals, but the manufacturers' manuals for the VNAs are, you know, typical Chinese stuff. But these are made in Croatia, and obviously they employed somebody from England because it's English, not American English, that they used. But it's a pretty good manual. And this is one of the screens. You can do a SWR measurement and get something that looks like this. Tells you, you know, if you're doing a single frequency. I'll get into the multi-frequency mode a little bit later on, or you can do the sweep and have something that looks like this, which is basically the same thing, just showing you over the 18 kilohertz, plus or minus 18 kilohertz. So this is, you know, throughout the 2 meter band, it's well below 1.5 SWR, or whatever antenna this was that I swept, I forget. This is the Smith chart, what it looks like, and same antenna, but with 9.375 kilohertz plus or minus. So you can see that antenna is pretty good. You can also get a phase chart, and where the green line's crossing the red line is basically, you know, quarter wave or half wave for the next one. So you need to be able to measure that particular point, as you'll see in a minute, because they are relatively expensive. These are the negatives of this device. They're relatively expensive, and you have to do some math if you want to find a coax length, so or a velocity factor, and you can do it. And there's the math. You know, if your velocity factor is known, you can use this math and end up with the length, which in this case happened to be 0.412 meters. And conversely, you can work at the velocity factor if you know the length. The reason I'm mentioning that is because this next baby, this one, the 55, actually will do that math for you, and you don't have to have a calculator handy as well. But as you can see, it only goes to 55 megahertz. It only uses 2 batteries, and is similar to the 600 in that it uses the USB to printer type cable to talk to the computer, and obviously uses the power from the computer as well. Does all the same stuff, you know, and the manual on this one is even better than the manual on the 600. It's as good a manual as you would find on any American piece of equipment. And the screen's a little different, of course. This is that same thing doing an SWR. You get a screen that looks like that. Both of them will do this feature, which is the multi-SWR. So you can plug in, you know, 5 different frequencies and see what the SWR is going to be at each of those frequencies. So whatever I was doing here was obviously good at 2494 and not very good elsewhere. One of the other things is this is what the sweep looks like. They actually, on the display, have the blue bands are all of the amateur bands for the US. So you can do a sweep. This happened to be the sweep of a wire antenna I have up, which is not particularly great. It's just slightly above the 7 megahertz, and you can see slightly below the that would be 17 megahertz, 18 megahertz. You can see the minimum there was 17.7. Is 1.38. So you get a sweep that looks like that. I'm going to actually later on show you a sweep. Our good friend, I believe that the antenna that I have on my roof once belonged to Mr. Avery. So the hex beam, I'll show you what the hex beam looks like later on. That's the SWR, and of course the return loss. You can look at that. This is also something that with the AA-600, you have to be plugged into the laptop to see it. And that's why I think this software is newer. And the reason why I wanted to show everybody both of them, because they are significantly different. Then moving on, there's on the menu structure, which I'll show you a little bit later on. The RigExpert 55 has one called Tools, where you can work out cable loss, cable impedance, work out the length for a stub tuner, or, for example, length and velocity factor of a piece of coax, which again I'm going to actually demonstrate for you. And that's what the screen looks like when you're in that mode. Let's move on to the AntScope 2 software interface. Is USB interface, so it's pretty standard. The software actually controls the analyzer functions, so you can plug stuff in on the AntScope screen, and it will change whatever is happening on the analyzer. So they do talk back and forth to each other, which is really good. And you can save and print in a number of different formats, which again I'll show you a bit more. And you can switch between all of the screens. This, for example, is what the analyzer screen looks like, the AntScope screen looks like. And this was one that I got off of their website. So it's actually from an AA230 zoom, which you can see up in the top left corner. You see the SWR phase, return loss, and time domain Smith. All of the others, phase, everything is up there. You can put markers, that's what the little triangles are, number them, and wherever the crosshairs are, that gives you a reference there as well. You can see the 154, 133. 3.52, so that's the frequency in SWR, which is also in the little box in the bottom left-hand corner as well. So it gives you everything you need to know, return loss, impedance, about that particular point where the crosshairs are. Excuse me. Up in the other little box up there where it says 1, 2, 3, 4, 5, the black box, that's the 1, 2, 3, 4, 5 markers, and it gives you SWR, return loss, impedance, phase, all of the information you need to know about those points. The this, by the way, is the sweep of it's a return loss graph of the hex beam that I have on my roof at the moment on the tower. So you can see anything over about 12, 14 is you're getting into very good return loss for antennas. So you can see that that hex beam is really good on everything except the 12-meter band, where it's just peaking at about 12. And you see on the 6-meter band on the far right there, the lower end of the 6-meter band, it's really good, and then it takes a dive. And so that hex beam is not particularly good on 6 meters. And then this is the SWR graph of the same antenna. So those of you used to looking at SWR, you can again see the SWR is tells you much the same information. The antenna is good on all of the bands. The 12, it's not quite as good, and the 6 is not very good at the higher end. So they both tell you the same thing. This is what an SWR looked like of a 400, UHF antenna that I have, that I put together. And you'll see there's 2 sweeps there. One of the things, because Mel's been to my house, so he knows but the rest of you don't, that from the front of the house, it's looks like a single story, but it's actually a 2-story and a walkout at the back. So the room I'm in right now is subterranean to the north of me, but it's walkout behind me. So one of the things I do when I'm making an antenna or tuning an antenna is in here, I will point it in several directions and make multiple sweeps like this one I did of a 2-meter antenna, and basically pointing it northeast, southwest, because I have a lot of electronic equipment on the north side, which is subterranean, not so much on the south side. And the point is that you should expect to see minor differences like that, but nothing major. And what it's going to tell me is that I should be able to take this antenna out, since the differences are minor. I should be able to take this antenna outside and put it somewhere and expect to see a very similar result. So that's why I use multiple sweeps. And then this was a Diamond BC103 antenna. And you can see on the Smith chart that it starts out just a little bit on the inductive side, and then goes through, a perfect 50 ohm point, and then goes somewhat capacitive. So, again, it's telling you everything you need to know about it. What I didn't mention earlier on, I will now, is you can see the settings here. This is where are you guys seeing my pointer, by the way?
Yes, we are.
Okay, good. So you can click export and export this, and it will go to your computer, and you can save it as a CSV or their own particular brand of file, or a couple of other formats. You can import one from your computer. So the advantage here is that you can do a sweep, export it to your computer, and then a year later come back, do another sweep, and compare the two, because you can import it and then do a sweep over the top of it and see whether or not your antenna has, something's changed on it. Likewise, you can print it as a PDF, as a JPEG, as a PNG, that kind of thing. You can do a screenshot of this. You can have many of them over here. Save them, open them, that kind of thing. Here you can change the number of points from 100 to 10,000 or something, some ridiculous number like that. The only difference is that obviously it's going to take much longer to do the sweep, but it will be an even more accurate sweep. And here's where you put your start and stop frequencies up here. So that's sorry. I'm sorry, I didn't catch that.
Yeah, I didn't catch it either. I'm sorry. Whoever asked the question, go ahead and ask it again.
Okay. Actually, I have the question on the graphs a couple of bit. This is Janet, WX7P. On when you were doing the hex beam, and my question is, can you expand that graph to make it bigger so you can see exactly where, get it down closer in terms of where you're resonant? Is that something you can do?
Yes, Johnny. You can. The way you would do that is basically. Let me see if I can step backwards here. Yeah, let's step backwards. Up. Okay, so there's the SWR graph. So what you can do is I did a sweep of the entire thing because I wanted to see all 6 bands. So the way to do what you want to do, you would go into the 20-meter band and just do a sweep, just a little bit either side of the 20-meter band, and then go to the 17 and the 15 and the 12 and do individual sweeps for each band. And then they would look something like that. Okay? So that answer your question, Janet? You're muted still.
Yes, you didn't answer the question.
Okay. Okay, good. Thanks. All right. Where do we get? Oh, yeah. Well, this was a slot cube antenna. I know you may remember John Portune had it in the QST magazine a couple of years ago. And I built several of them, gave them to friends who didn't have a decent 2-meter antenna. And as you can see, it's a fairly decent antenna. That was the Smith chart for it. And this again was the Diamond BC 103, and this is the return loss for that same antenna. And now we're going to move on to the nano VNAs. Like I said, the basic one is sort of skeleton. It's not in a box. It's a sandwich of 3 PCBs with a battery in between the lower 2 and some other electronics between the screen and the center one. You can see that looking at the white one, there's a knob or a switch or whatever you want to call it that sticks out fairly far on the top right hand edge of it. It is very I'm trying to think of, let's put it this way, one could easily break it off, you know, so it's very fragile. That's what I was looking for. So you have to be careful with it. But, you know, for $40, I was in awe when I first got it. They, like I said, they run for $40.50 in the skeletal version, $75 in a little metal case, and around $100 to $139 for the F version, which I have both of them. So I'm going to show you. You'll see the difference in the screen. Obviously, the F one I bought later, and it has even better, newer software in it as well. And it uses SMA connectors, as you can see. And it does, let's move on to the next one. It does everything that the other guys do, and a little more. Because it does S21 measurements as well. I'm not going to get into those, but it's just something that the others don't do. Even the $500 one. Inexpensive, small. It's a touch screen, so you know obviously there will be some wear there over time. And as I explained, the cases are the difference. The small one, the problem with it is, as you will see shortly, it is small, it's hard to read. The switch, as I said, is delicate. SMAs are delicate. In fact, they tell you, they give you a pair of SMA to SMA cables, and they tell you do not put an adapter onto the SMA, you know, an adapter to an SO239 on the actual SMA that's on the edge of the device, because it's fragile and you'll break it off. So they give you, they're 6 or 8 inches, yeah, about 8-inch long cables that go SMA to SMA, and then you can put your adapter on that end, and that takes the strain off of the one that's on the edge of the board. That's what they look like. This is basically what the screen tells you. You have your start-stop frequencies at the bottom there. You've got markers, the same as the expensive ones. You've got there's a calibration status there, reference position. Markers up at the top tells you as you can have a Smith chart. This is their picture, and they had everything going all at the same time, so it's a bit messy. You could turn off the traces. There are 4 traces, and you can turn them on and off, which I'll show you. When you do want to change the frequency, you hit stimulus, and when you hit stimulus, you get another screen that says start, stop. And then you get this one here, and there's the start stop. So you would, and if you wanted to check, you know, 6-meter antenna or something, you could punch in 50 M for your start and 54 M for your stop frequency, that kind of thing, or you know, whatever band you want to look at. You just punch that in, and then of course it will do the sweep. One of the cool things you can get, this is actually an extra, and I think they're running about $27 for people who are not used to looking at Smith charts and stuff. You might not be able to see it, but there are little connectors on here, and this is a PCB that's $27, and you get the cables that plug into it. So it's a micro SMA type connector, as you can see on the ends of those 2 cables. But this way you can have a look, and it shows you what a capacitor and a, you know, a low pass filter, a high pass filter, attenuation, perfect load, open, short. It shows you what they would look like, you know. So it's a good learning tool for somebody that's not used to looking at Smith charts. And this is the software that's on the computer. And you can, they don't have it, SWR here, but you would go down here and hit display setup and change one of these to show SWR instead of phase if that's what you would like. These three, they're blue, red, green. You can just see them. There's the red, there's the blue, and the green's over there. Those are markers, just the same as you had on the screen that's on the device. Here's where you put your start and stop frequency. So it's similar to the RigExpert and Scope software in that respect. And you would tell it to do a sweep here, and my internet connection says it's unstable. It's done that a couple of times. Where these markers are, it then tells you the frequency, the impedance, what the impedance is made out of, and you know, in terms of inductance, capacitance, it gives you the return loss, the SWR, and that for each of those three markers. So, you know, pretty much everything you might want to know about your antenna. So that's that software. And now we get to the 269 Pro. And mine was around to $450. And it does, you know, like I said, 1.8 to 170 megahertz. And then it does 415 to 520. So it covers the VHF and UHF bands. However, the UHF it does not give you the impedance. It only gives you the SWR. Has an N connector. It uses 10 batteries. AA batteries is rechargeable. It does have a up at the top here, this is the external power supply plug into the socket there. So you can have a 12-volt supply feeding it, so you can use external power. But of course that ties it down to your desk for sure. But you can do, you know, all of the same stuff. Everything you can do with the other ones is just that you have to use these buttons here. So I'll show you right now. It's very power hungry with the batteries. They don't last any longer. The 10 batteries don't last any longer than the 3 batteries in the 600 or the 2 batteries in the 55. It's very heavily menu driven. Everything appears up here, but you have to push this button, that button, sometimes both buttons, and then one of the other buttons. So you know, if you don't use it a lot, you end up having to have the manual there, where both of the RigExpert ones are pretty much self-explanatory. You know, I mean, it's not anywhere near as menu driven as this thing is. It is in a sturdy metal case, but I've managed to bend these wings a little bit on my a drop does that. It's pretty heavy, of course, with 10 batteries compared to the other ones, and certainly less convenient for power use. One of the other things you can do, of course, is you can use the same math that we used on the 600 with the nano VNAs to, you know, find a resonant frequency, that kind of thing. Or you can find a capacitor or inductor measurement. So with that, let's see them in use. Now, what I've got to do is stop sharing this screen for a minute, and this would be a good time for everybody to take a potty break if they want.
By the way, I would say one of the things that I really like about the RigExperts is that you can take a picture of any screen you want. And then, like I know when I was working on my stepper, I took all my screenshots and sent them to Adam, and he was able to analyze all of them from the west side while I was over here, and it was really quite convenient. They were very clear and crisp, and gave a lot of detail. So I did like that about the RigExpert.
You know, one comment that I have on the 600, I've got one. It's maybe a little bit hidden on the menu, but there is a way to plug in the velocity factor and get a reading in length. I've done it many times.
Yes.
It's buried in the menus. It's not as convenient as 54, 55, but it's there. If you dig for it, you can find it.
Yeah,
I've got a question.
that is true.
Where
It just takes a lot more work than the 55 does.
yeah, the 55's really got nice software from the looks of it.
Oh man.
Okay. Can you all see the hardware now?
No, it's not up yet.
Oh, yes, of course not. I have to hit the button called share.
No. File.
Now can you see it?
Yeah, we see it now.
Yes, sir.
Okay. All right. I'm going to move over and move the microphone. So first thing I'll show you is the difference in the size of the Nano VNA versus the VNA F, which is this one. And you can see that's a skeletal one. This one's in a nice metal box. So that thing right there at the bottom is the battery. But there's the switch, the connector, the USB right there, the on-off switch, and the one that I was telling you about that is fragile because this goes left, right, and in as well to make selections. So you can actually operate it using that button, that switch, but it's much easier to use the touch screen. But let's take, first of all, we'll take them in the same order that we had them in the presentation. So here's the RigExpert. Let me move the others out of the way a second. So I want to do they both have this function switch here, and if you push function 7, it gets you to the multi. Otherwise, you're doing SWR, or you can do function Smith chart would be 5. So look at the menu. We want to do a scan the SWR. So just so you understand what I'm scanning right now, I have a 2-meter antenna behind me mounted on top of my component rack. So we'll just do a sweep of that, press the 4 button. You can see I've got the frequency set for 151 plus or minus 9.375. I don't know why they picked these odd numbers, but the way you change that is there's the range change. So you go, it's up and down by these strange numbers, plus or minus 4, plus or minus 9, etc., plus or minus 18. Well, this antenna that I've got behind me is a wideband 2-meter antenna because we're putting up a repeater system for the scope. That's those of you who don't know, that's the Spokane County Sheriff's community-oriented policing effort, of which both Peter and I are involved with. This repeater system we're trying to put up is going to transmit at 153 and receive at 159. So our vehicles need to transmit at 159, but we also, because many of us, there's quite a few of us that are amateurs, radio operators, we wanted also to be able to have the radios in the cars be able to go down to the ham band so we could talk to each other on those frequencies as well, which is why we needed an antenna that had about a 20 megahertz bandwidth. And as soon as you press OK, this is what you see. And that's how long it takes to do a sweep. So you can see that from 100, 142 to 159, it's below 1.5. So pretty good antenna. So that's all you have to do there. If you wanted to do the multi thing, then you can go in and you can put in your different frequencies there. I won't bother doing that, but I just wanted to show you the one thing with this one, because they're all very similar, so no point boring you with watching all of them. This is, oh, by the way, the 55 has a SO239, so this is I'm going to do a sweep on the there we go.
Just don't plug your SO39 into an end connector.
What?
Been there and done that. It's not good.
Yes. I've used end connectors all the way up to my antenna. So just to reduce, well, because they're a better connector. Anyway, so yeah, that's a PL259 to N.
Correct.
Anyway.
He's wrong.
Anyway, this is where it comes up, and it says, we wanted, there we go. So want to do the same thing with this one, to do a sweep of that, and we'll just hit OK, because it's already on there, and we've got, I have it set for 33 megahertz plus or minus 25, and that's what it looks like on this device. It's showing me, you remember the sweep you saw earlier on? The 12 meter wasn't so good, the 6 meter wasn't so good. And so it's telling us that antenna hasn't changed, since I last did the sweep on it. So now we can take this and we can, put it on the computer if we want to. But I wanted to show you one more thing with this one, because Mel actually asked me about this a while back. I happen to have right here the end of a piece of coax. And if you don't know how long the coax is, but you do know the velocity factor, then we go to Function, Tools, and let's go down there. Go down to the length and velocity factor, hit OK. The default comes up with a velocity factor of 66, so let's just go with that and see, And it says it's 51 feet, 0.68. Well, as it happens, I know this is only 50 feet long, so we will do the reverse. So come down here and we'll find out what the true velocity factor is. And there you go. So that is something that the 600 doesn't do, the nanos won't do that easily. You can, with a calculator and a lot of workarounds, you can do the same thing. But this thing is just, well, in my opinion, awesome, because it saves a lot of headaches and work. Okay, so that was all I really wanted to show you with that one. And now we'll show you the Nano VNA. So this is the baby Nano VNA. Maybe I can bring the camera. No, can't get it. Hope that didn't make you too sick. Okay, so touch screen. Like I said, it's gonna be hard for you to see, but I'm gonna go stimulus, start frequency, and then go. Oh, by the way, what I've got right here, this thing, is a 2-meter antenna mounted to the desk here at the moment. I didn't know this antenna coil didn't have, when I got it, didn't have a stainless steel rod. So I put some welding rod in there, and I was playing around trying to find out where it would be resonant. So I'm going to put in 140 megahertz. Yeah, all right, that'll do. And then stop frequency, we'll put in 150 megahertz again, and there it does the sweep. And what you can see, just about anyway, is this is a Smith chart one. The purple one, which is harder to see, I don't know if I can bring it up closer to the camera. Yeah, there you go. So the purple one is the SWR. It's changing because my hand is getting close to the antenna. I moved it away there. And the yellow one is the return loss. So you can see up at the top, it tells you there the return loss. Below it, it tells you the SWR. So that's what that baby looks like. And this is not a cable that comes with it. You have to buy this extra cable. So let's turn that off and show you what this guy looks like, because the switch is on the end here. So we'll turn that guy on, and already you can see that it's much brighter, bigger, and it has a scale down on the side here that the other one didn't have. So you actually had to, with the other one, you had to go in and set the scale, which you can adjust it, for half of it, like a SWR of 0.5, for each division. This comes up with a scale on the side already. So we can go in and we'll turn off, we can turn some of the traces off so it's not quite so busy. We'll turn that one off there as well. And stimulus start, 144. And there I've got just the Smith chart and the return loss on there. And the return loss is -11. And we can go in and change any of any one of these to show us SWR if we want. So, you know, it's, let's, and the other thing is we can put in these markers. We can take a marker down, move it around, find our sweet spot, adjust it. This is changing because this antenna is right in my way here. So anyway, that gives you an idea of how much bigger this guy is and how much easier it is to see everything. As you can see, I have a cable here, and that's with this one, what you would use to display this onto the computer. So I think that pretty much covers everything. If anybody has any questions about any of these.
Okay, if you've got questions, make sure you unmute your mic.
Hey, this is Peter. I have that Nano F, and this is all fairly new to me, but it's so simple to use. I just looked at a couple charts and was able to get up and really do a quick scan. I've got a new Wolf River coil system that I'm really looking forward to doing. And for $100, you can't beat it. So I really highly recommend it. It's very simple to use, and it's big enough that I don't really need to hook it up to the computer. I mean, I could just sit there at my desk, and it's very clear. So
yeah,
try it.
As you can see up here, you can probably just see that says log mag right there. I mean, it is so much more readable than the small one, but the small one fits in your shirt pocket. You know, this one's a little bulky for your shirt pocket, but you know, if you're going to climb a tower, you can take this up with you. You can do a sweep, save it on these devices, and then come down and then plug it into your computer and do a print.
Yeah,
So,
Jeff, that lets you save 5 reference points, doesn't it?
yes, yeah, it is. Actually, I forget now.
I think it's 5.
5, yeah.
Yeah, 5 points, yeah.
Yeah. And, you know, and then it would just kind of record over itself, you know, after that.
Yeah.
Okay, well, Jeff, thank you. And if you have questions, you know how to get him. I think it was nice to be able to see the difference between them. And I think it's good for us to kind of get an idea on different ones.